In this lecture, we're going to learn about range-based for loops. Before we do that though, let's review what we had before. We had to specify an iterator, which is that I variable really that we use to control the loop. Through that iterator, we had to specify the starting point. And the starting point in this case is 0 because we are using braced initializer. After that, we had to specify the end condition for the loop. And this loop is going to end when I is no longer less than 10. After that, we need to specify an incrementation or something that is going to control how the loop is going to move forward. These things are a lot to do, and in some applications, you don't really want to go through all this trouble. All you want to do is access the value and use it right away. And that's what range-based for loops really do. They help you avoid the overhead of having to set up an iterator, to test for the end case of the loop, to do the incrementation, and you can really directly focus on getting the value you want. But one thing you should know is that range-based for loops really work on collection types. And I have to apologize because I'm going to try and use something we haven't learned about yet, because we need to learn about range-based for loops. I am going to do my best and make sure you really drive this home. So here we have a variable declared. It is an integer, and we call it bag of values. We call it like this because it's going to be a collection of integers. And if you want this thing to be a collection, you're going to add these angle brackets. Once you do this, the compiler is going to know that you are trying to declare a collection of integers, and it's going to allow you to initialize like we do here. We're going to set up a pair of curly braces, and inside we're going to put in a comma-separated list of our integers. If we do this, we will have a collection of integers, and we can use a range-based for loop to iterate over this and get the values in our collection and use it in the body of the loop. And the syntax for a range-based for loop really looks like this. You say for, you put a pair of parentheses, you set up a variable that is going to capture the current value in the collection, and then you specify the collection from which you're going to be getting those values. So what we really are doing here is we are telling the loop to give us every single value it has in order. So if we print value here, we're going to get 1, 2, 3, all the way to 10. And this is how you do it. And you see that we can solely focus on the value we are getting from the loop without having to set up the initial value for the iterator, the end condition for the loop, and the incrementation. We can really kind of ignore those things and focus on the value that we are getting from our collection here. Okay, here you see that we had to specify our collection outside the loop, but we can also specify the collection in place, and we can do it like this. And this is going to give us the same output as we had in the previous slide. We can also let the compiler deduce the type. You see, we're not specifying what type is stored in this collection, and the compiler is going to deduce this and print this. And again, here we're going to get the same output. I am just showing you different ways to use these things. Okay, another thing I want to talk about here is the scope of this value here. It is going to be scoped within this loop, and you can't use it outside this for loop. If you try to do that, you're going to get a compiler error. And that's what we are saying here. Okay, that's really all I have to say about range-based for loops. The main thing they are used for is to get values from collections like we just did in the slides here, and they help you avoid the overhead of having to set up an iterator, the starting point, the test for the loop, and the incrementation part of the loop, and you can really focus on the loop body and use that to get values from that collection and do things with that value. We're going to head to Visual Studio Code and actually see this in action. Okay, here we are in our working folder. We're going to grab our template files. We're going to copy that and put that in the current project, which is range-based for loop. We're going to go in and paste in our files. And we're going to open this in Visual Studio Code as we always do. So let's do that. We open up our main CPP file and get rid of what we don't need here. And we are going to go down and put in our code to play with range-based for loops. Let's go on the left here and get rid of this pane here because we're going to be able to see everything. So we have our declaration for our collection of integers. Let's say that this is a collection. We don't really have the specifics to understand this yet, but for now, think of it as a collection of integers, and we're going to be getting values from this and print them in our range-based for loop. Okay, so if we go down here, we're going to get our range-based for loop. This is the syntax we use. We are basically saying we're going to be looping over the values in here and getting each one at every iteration of this for loop here. And this side, we're going to be capturing the value and printing it out. You have to capture the value in a variable, so we set up a variable which is an integer called value here. And we specified that these values are going to be coming from this collection here. And this is the syntax we use. You put a colon and put the name of the collection you want to iterate over. Inside, you're going to capture your value in this variable here, so we're going to print it out. And this thing is going to print 1, 2, 3, 4, all the way to 10 if we run this. So let's try to do that. We're going to bring up a terminal here so that we see everything. And we're going to build with GCC as we always do. The build is going to be good. If we run this, we're going to get value 1 all the way through 10. And this is really cool. You see that we didn't have to set up an iterator or the int value that we really use to iterate over things. If you wanted to do this the old way, you would have to do something like this. But this is not something we have learned about. But I just want you to be able to compare this to the old way of doing this, and you're going to be able to appreciate the simplicity of this. So what we would have to do if we had to do this with the old for loop, we would say for size t, I, and I will initialize this with a 0. We're going to say I less than the number of elements in here. We have 10 elements, so we're going to hard code this in for simplicity, but this is not something you should do in practice. You should put these values in variables, and that would allow you to control this easily. So we're going to say plus plus I, and inside, we're going to do stdcout value. And there is a special syntax we use to get values from this kind of collection we are using here. And that's saying bag of values and specify the index where we want to get the value in the collection here. Again, I don't expect you to understand this. We are doing this to show you that you don't have to do the same things in a ranged base for loop. So if we run this loop, it's going to give you the exact same output here. So let's bring this up and clear. And we're going to build with GCC. The build is going to be good. And if we clear and run Rooster, you're going to see we're going to get the same thing. But we had to set up this iterator, which is I. We had to test for the end condition. We had to increment. And we can avoid all this by saying we just want to get a value from this bag of collection. And we can simplify this by just saying we want to get this value from this collection, and we can print it out. And this can be much simpler to read and work with in a professional C++ code. So for collections, we're going to be using this syntax to read things because it is much easier. Again, sorry, this is not something we have learned about yet. For example, this syntax is not clear yet. You can ignore this and just appreciate the fact that we didn't have to do all this setup in a ranged base flow loop. We're going to learn about this actually in the next chapter, so bear with me and you're going to understand how this collection works. Okay, let's comment this out. The next thing we're going to see is that we can also specify the collection in place. And we can go down and put in code to do that. I don't want to type all this. You can type this if you want. But we're just going to move the collection inside instead of having to define it on the outside like this. And this is going to give us the exact same output. Again, the syntax is the same for our range-based for loop. We specify the value which is going to capture data inside our collection, and then we specify the collection, and the rest is really the same. So if we build this, we're going to run the build with GCC, and if we clear and run Rooster, we're going to get the exact same output here. The last thing I want you to see is that we can also do auto type deduction for this int value. In other words, we don't have to specify the type here. we can use auto type deduction. So let's go down and do that. So we can put in our code to do that. And you see that we say auto. And the rest is really the same. And again, if we run this, it is going to work as we expect. And it is going to give us the exact same output here. So let's do that. We're going to build with GCC. The build is going to go through. Let's clear properly and run Rooster. The values are exactly what we expect from 1 all the way to 10. And this is really all I had to share in this lecture. I hope now you have a better understanding of how ranged-based for loops work. They are mainly used to get values from collections, and the main goal for them is to avoid the overhead to have to set up an iterator, the test and the incrementation part, and directly focus on getting a value from a collection. And once you have that value, you can work with it and do whatever it is you want to do in your application. We are going to stop here in this lecture. In the next one, we're going to learn about while loops. Go ahead and finish up here and meet me there.